today. This panel is Decentralized Infrastructure for Autonomous AI. I'm really excited about this. It kind of continues off of our kickoff conversation, and I think a lot of the subjects they hit really got your mind flowing about where this is going to go and how important this discussion is going to be over the next couple of years. So I'm really excited that I'm joined by 4 kind of pioneering projects in different areas that are going to all have a big impact on where this is going. I want to jump right in, though, and kind of hand the mic to each of you. I'm going to have you introduce yourself and your project really briefly, but at the same time, I want you to answer the question, why does autonomous AI matter right now? Why are we on this stage? And you can answer it from your project's perspective or the world's perspective, I don't mind. But why don't we just go down the line here?
Yeah, sure. Thanks for the intro. Nice to be here. I'm Chris from Vanna. I'm the I lead engineering there. Before that, let's see where to start. I started with AI back when it was like really much more infant technology. In high school, trained some models in being able to find cancers, predict if they're able to, which drugs might be effective, how do we treat people better at MIT. In high school, did a bunch of stuff in between, and then went back and was on the research team at one of the organizations that trained one of the first open weight GPT models. Wrote some optimizers, did some hyperparameter tuning, it was awesome, and then kind of got into Web3, started looking around and met Anna and the team, which I thought that it was a super compelling pitch, compelling use case where over at Vanna we're building the L1 and the infrastructure to really take self-sovereign control over your data and be able to sell it, use it, travel with it wherever you want, and really taking your own data, your own personalized data as like a part of your ritual. And that's just a super cool story to me where relating to your question of why do we need autonomous AI right now and how, like, what are the, I'm going to flip that a little bit into where are the places that it's going to impact. I think it's going to impact a lot of our lives. If we look at the way that the world will look 10 years from now, you ask anybody across the spectrum, and we're going to see a lot more AI, we're going to see a lot more automation, we're going to see a lot more value capture on this layer, where if you look at the data that's being used to build it, enabling users to cross their data from across all of these walled gardens like Facebook, Google, Amazon, etc., and bring it into one core place where they can travel with it. They can use AIs that are super enhanced by it. I think that'll be amazing.
I was Zach. I'm the head of marketing for Akash. So for anyone that hasn't heard of Akash, Akash is a decentralized marketplace for cloud compute. So you can think about AWS or GCP. Akash is the decentralized version of that. So big distributed network of providers around the world that bring their compute to the marketplace that matches with deployers around the world that want to access that compute. Akash is the orchestration layer that coordinates the workloads and pricing. To the question on why we need autonomous AI, we have a booth at the main venue this year, and I've been having nonstop conversations with builders, right? I had one earlier today with this team that's doing fine-tuning. They're building out models for research use cases, and fundamentally they go to these hyperscale providers, AWS in this case, and they're looking for H100s. They can't access those GPUs at a price they can afford. It's just way outside of their price point. So fundamentally, it's, in my mind, just from the compute side, it's really about access to compute. Like, how do we get compute in the hands of builders that need it in a way that they can do these experiments and build these applications that are only fundamentally possible with decentralized compute? And that's just, it's a unique use case, and there's so much happening right now. So in my mind, it's just about getting the resources in the hands of people that can do this work and then letting them go,
Hi everyone, this is Tim. I'm currently the infra partnership lead and validator lead at Story. So I actually has a background in high performance computing, so computation, and previously worked at Flock.io. Fabric Learning was a blockchain as a head of that field, so pretty rich background in AI. So at Story, when we look at autonomous AI, we tackle down into a problem with one, model licensing. So like we have a lot of open source model, but the monetization part is an issue. Like how you sustainably running the model, how you contribute to open source model is also a question. Like when you see model and fine tuning, that relationship can be parents model and then you remix on the model and then you kind of have the child model. And then the other part we're looking at is the content generated by AI. How do we identify your data input into the model and also the data output of the model? How we identify the ownership? I think that is also a very important question we want to tackle down with the AI era.
Hi, I'm the other Tim. You may know me from such meme coins as autonomous virtual beings. I see some of you back there. Hey. Yeah, but when I'm not coordinating a community who made a meme coin based on my blog, I'm the founder of Scripted, and we are building a layer 1 for AI agents called Winori. And I actually got my start in the industry as an AI programmer at Electronic Arts on the first generation of massively multiplayer online games. As you can imagine, I have always seen this power of having hundreds of thousands of agents, whether they're human or artificial, creating more emergent behavior and content. And unfortunately, back in the late 90s and early 2000s, even before deep learning, we didn't have the computational power per second to really make this happen. Now we do, which is why I really care about autonomous AI, because I have to sleep. I would love to have opportunities seized on my behalf by AI. And unfortunately, right now, a lot of people are spending time on, ooh, let's watch your wallet and do trading the same way that you would. And I'm like, no, I don't want an AI agent to do what I would do in my wallet. I'm a bad trader. But know what I think like and what I care about, execute on that. Now we're talking. I really like that idea.
Thanks. Okay, so I think each of you touched on this a little bit, but let's dig in a little bit more to the kind of, I'm thinking of like the YouTube viewers after this, actually. The folks that are going to get this fed up in their feed and they're going to go, wait a second, the foundational value prop of decentralization. Why crypto, why tokens, why AI, all of that? Why don't we start down there? Why do you think that this combo makes sense and what is it providing?
Yeah. Okay. I have a tendency to talk too much, so forgive me in advance. There's two parts to me. First is the very Chris Dixon-y rewrite loan kind of how do you align incentives? And at this point, we're talking about aligning incentives for AI and humans, or even AI and autonomous AI and network services like Akash, or through protocols like Story. When I think about these things, I want to see a future where these agents can grow and learn autonomously. And the only way to really do that at scale, because there are only so many GPUs in the world and monolithic companies are already running out of them. OpenAI just announced they're already out of GPUs, right? Well, how are we going to get one-to-one humans and autonomous agents unless we actually solve sharding, if we solve scaling? Decentralization has promised us this for a long time. I want to solve in that vertical.
Yeah, just touch base on computation parts is hold a slightly better kind of, into the computation. When we look at computation, I think we are currently short in that singular computation kind of situation. When we look at data center, like how much computation power can one data center hold? And then you start thinking about, can we actually aggregate multiple data centers? For example, through Akash network currently has a lot of decentralized computation, or using a specific framework, such as Flower Lab, they have the vertical federated learning method. But still, you get to a point when training a larger and larger and larger model, it requires larger volume of computation power. I think we've been talking about using idle computation for a long time, but it still seems to be a very hard topic, especially sharding, right? Like one task, and then you split it into multiple computation resources, and then how we aggregate back. But this is very important because one data center can only hold, for example, like I think it's around like 10K a graphic card. Then if you want 60K graphic card, you need to build a new center, but there won't be that much space for you to build that 60K graphic card like data center. Then you need to start using multiple data centers computation power together to actually train a larger model to serve the future of human beings. Yeah.
I have thoughts on that, but I want you guys to talk.
I'll jump in. I mean, there's a million ways you can take that question, especially on the compute side, but the one that I'll go down is permissionless access, right? So if you think about agents and agentic workflows and things like that, fundamentally you need a protocol on the compute side that's permissionless to access, as in there's no KYC, you don't need to set up an account, there's no terms of service, right? Agents can come in, they can deploy on Akash in this case, but on other networks as well, and they can self-replicate, which is the key. So we have a developer working right now on Akash who's doing a computer use agent. Essentially, it uses the UI, ChatGPT or OpenAI launched Operator. Very similar. It uses the same UI that we all use, right? But what it can do is you set it loose on Akash, so to speak, and it can self-replicate itself. It can manage its own workloads. It can deploy new versions of itself. It can expand its resources. It can track. And because it's crypto assets, right, and wallet, it can control its own funds. So that is fundamentally, in my mind, the direction that we need to be heading is towards these permissionless networks that don't have gatekeepers, that don't have centralization, right? To allow agents to self-replicate and to do what they do.
I want to take some of the compute side, which I would love to get to. On the data side, though, I think there's a really compelling and a really differentiated story. Well, wife lives on my phone, lives in my wallet, lives in my online presence. And it turns out if you look at that, you're able to upload it, you're able to use its context, you're able to augment the AI with the knowledge of my preferences, how I behave, and how I live my life. You actually get a lot better at it now. But right now, in each of these centralized data systems, you've got like Google will have one silo of data, Amazon will have one silo of data, Facebook will have one silo of data, Telegram will have a completely different one, where the value that you get by an individual level combining that and being able to use that for AI is actually really good. And in terms of why crypto, really it's this idea of self-sovereignty, being able to take my data, access it unmolested, run it unmolested across the whole system, and get the results that I need with the confidence that isn't being stolen or used for purposes that I don't care about and I really hate. Being able to do that is a really amazing thing, and that's what we're enabling at Thought. On the compute side, I think that I believe strongly in the decentralized compute story. If you look at data centers, something like 90% of the cost is in the chips right now. We don't have megawatts. This is not true if you use the decentralized computing centers, or you can break some of these barriers if you use decentralized compute in a very, very, very intelligent way. And you solve all the coordinations. Inference is not so bad. Multi-inference or multi-card inference is, starts getting there. Multi-data center, whenever you start doing that, it gets a little weird.
Can I just jump in for a second? Because, by the way, something Anna told me yesterday just blew my mind. And I won't say which social network, but you guys have trained a model with licensing, because you are the data sourcers, from one of the largest social networks, right? And that is an incredibly valuable thing. But one of the problems we have in the industry, and this is kind of what Tim was touching on a little bit, is that we have very big hammers. We have large language models, we have diffusion networks. And when you have such large, attractive, value accruing hammers, every problem in AI looks like a nail, including just ignoring like the last 60, 70 years of symbolic AI, like the ORI stuff, like if-else conditionals and all sorts of things that are like actually just procedurally generated, right? But when you mix those kind of systems together, suddenly you massively reduce the amount you need for inference, but you also increase the amount of actual capability and the need to deploy more stuff, right?
Well, it's a maximum intelligence per flop sync per GPU cycle, right? You want the architecture that gives you the maximum intelligence, which for whatever reason transformers are, right? And then transformers augmented with the system around it. And, when you look at the decentralized compute paradigm, if you look at the energy that we spend Bitcoin mining, it's actually on par with most of the hyperscalers, which is really cool.
Yeah.
And flops roughly equals intelligence. That's kind of the equation that you solve for. Then when you consider data in that story,
it's going back to that. Solving for intelligence more than inference, because like when DeepSeek came out and kind of nuked everything for a hot minute, right? Everyone's theory was, oh no, we're not going to need as many cards. like, even if we optimize intelligence and we use things that aren't just purely inference, it still makes distributed computing really valuable because you can just do more, right? You can just do more per second.
It's a possibility of volume. So it's the possibility of access to more like computation power when we look at this, like compare how much we can exactly get and then compare it to how much you can actually use. Yeah.
Yeah, so actually that is a halfway to a question I had, which is on the compute side. Totally. How competitive are we with the hyperscalers, and what do we still need to actually do to be competitive?
I'll jump in on that. I mean, there's a lot, right? Depends if you're thinking about features and functionality, of which, yeah, there's ways to go, right? There's services and functionality you can get on AWS and GCP that you can on the decentralized networks today, but just take cost, right? So on H100 SSM 580 gigs, you go to AWS, you rent one of those on demand, you have to get a cluster if you go to AWS, but per GPU per hour, it's $12.29. On a cost, it's $1.12. So that's 90% less. So there's a trade-off, right? It's like you're missing some features of functionality, but you get this, massively reduced cost. And for most people, that's a trade they're willing to make, and they'll work around the features and the functionality.
Actually, can I jump in? I used Akash. So the Flock tutorial on deploying Akash was written by myself. So I actually had a try. The maternity is called. I think the good thing about Akash is that you are matching the demand and supply. For example, when we use AWS, we use GCP, you kind of get preset servers that they give you. So then the cost will be skyrocket high because they run in the same data center or operating center. But for Akash or decentralized compute is the fact that you matching, it's more like a P2P relationship. You are matching directly to the person where they don't have any middleman cost. It's just the operational cost, the electronic cost for the person that is renting the card out, and then you are utilizing the network. I think that's a huge improvement to us, that we are eliminating the middleman cost that we foreseen. For example, AWS costs really a lot if you're trying to run a extra large server for like so I in charge of the validator at Story. So I do have several XLarge cluster to run the nodes. That costs a lot. So that we are able to use decentralized compute to resolve that. It's more like a demand and supply P2P relationship rather than a centralized authority controlling and then set the price for you. Yeah.
And go ahead.
I believe the story that decentralized compute is cheaper than centralized compute. I think that comparing to neoclouds, like Lambda Labs is probably the right metric. And within there, if you look at really what you're trading off is looked at a couple of Bitcoin mining businesses, seen some Ethereum miners like can trade the photos. You're trading off some when you build a Web2 data center, you're building it for web apps where the vast majority of the value is in the web app. And you just don't care about the cost of compute because AI is not that way anymore because it's flops equals intelligence equals output, roughly. With the augmentation of the data, with the augmentation of the if-else and all the other conditionals that you really need to make the system perform. And if you look at that, really what you're trading off is like cheaper electricity or electricity, much worse conditions of data centers, but it actually doesn't matter for the application that you're running because the only thing that you care about is cost efficiency, and people haven't really been optimizing for that so much, or at least not in the we don't care about 4 nines of uptime, we just care about 95% uptime, and we can dynamically reroute stuff, plus older chips, plus smaller data centers in random places.
So I'm trying to put myself in the place of an AI, and that's a little weird, but after all, I am just a diffusion model with a bunch of LLM processes I'm deployed. So when I think about the other dimension that's not just pure computational cost savings, the other advantage to decentralized compute, right, is, you called it out, the lack of KYC, the ability to have programmatic access and programmatic freedom to access resources. And if we're going to actually try, and we are doing this, to even in parts create autonomous agents that are just continuously running, they can't be beholden to my wallet sitting there trying to transfer some USD somewhere to make a payment. They need to be able to be on native rails like crypto to pay for decentralized services.
So I've heard it come up a few times, the autonomous agent living on decentralized rails. So I guess the question is just, how close are we to one of those agents being fully autonomous, being sovereign, in some sense, and actually producing something valuable?
I mean, like, I have strong opinions about this. So, like, I mean, we have all the pieces. Like, we have every component necessary to create a fully autonomous being. We can do this. It's a question of, right now with the current crypto networks, a lot of them are focused on fully deterministic computation, and for good reasons, credible neutrality and provable fairness. Solving for being able to verify at speed non-deterministic and fuzzy calculations. In other words, not having to rely on like ZK rollups. And there's nothing wrong with ZK. I'm just saying for this particular case. That's one sticking point that I think some of us are very interested in solving. But the pieces are there. As long as you're willing to accept an autonomous agent is not just one Python script running on one AWS container. If you're willing to make it in parts running on many different services and call all of it an agent, we're good. We got that.
Could be. Thoughts on that one?
I think again, like I'm pretty much agree on that. Like I mean, like if you even if you run on an AWS, it just interact with the chain, and then it's just you kind of set a mission for it. It is running. It's not as decentralized as we expected. I think it's just the part of the topic here is autonomous agent or more on a decentralized infrastructure. I think the decentralized infrastructure may not yet be at the point to support everything.
Built in it.
Yeah. Yeah, because likewise, when we talk about AI, it's some sort of, from my perspective, like AI or computation is the maximum of centralization before decentralized computation came out. Like putting a very centralized object onto a decentralized infrastructure take time. It's about like whether, for example, whether consensus module kicks into the AI sovereignty or kick into the AI agent choice. Because if you deploy your AI agent on multi-party, like how does that choice gonna be effective? Do you need how your consensus layer gonna work? Because when we talk about decentralization, we cannot ease out the consensus layer. We need majority of the people to agree on that consensus layer or using the native distributed ledger. So everyone need to have the log of your choice. Then it becomes a harder question, right? How AI agent gonna decide? Is AI agent gonna run the like a low level infrastructure, or is the human gonna run the low level infrastructure? And then who gonna make the decision of consensus? I think that likewise, if it's a Python script on AWS, we are there. But if it's more like if we talk more into the decentralization part, we need to think more deeper into the consensus layer, how that consensus can play around with the AI agent. I think we're yet getting there.
I think a lot of the pieces are in place, and it's just a matter of time. And just based on some like the early experiments that I've seen over the last couple of months, like that are just starting to come out now, give it another 6 months or a year, I think we'll have autonomous agents on decentralized compute that are doing useful things. To your point,
Yes,
it's coming. Just give it some time.
But none of you answered what the value, like what would they be doing that would be valuable?
I think that's up to the builder, right? It's like it's about like how many experiments can you take? How many shots on goal can you take, right? Like how many apps can you come up with? How much compute can you get to solve for, and then let the market decide what's useful?
Yeah, I'm just going to play directly off this. That's like asking, what are humans good for? And humans are good for $100 trillion of GDP annually across this planet. And if agents begin doing the same thing by having evolving strategies, by making derivatives of themselves, as becoming vehicles for both creativity and investment, where we're seeing agents even now that are still centralized and controlled by humans become truly decentralized, and they're showing us new versions of themselves that some are going to fail, some are going to be interesting. Yeah, there's value because it's automated and it's fast. And suddenly, apparently some of our friends are building robots for you.
You must be seeing ideas of how people are expecting to transact with the user.
Expecting to transact with user data, like what applications that they want to build.
Yeah, exactly. Yeah. Are you seeing valuable use cases here?
Yeah, absolutely. We're seeing early use cases built on valuable data and early valuable use cases as well. Some of the ones that I really like. First, you've got Reddit Data, which went off and trained a model based on that. And I think they're using it for a better moderator agent, which is, early stages. That was about a year ago, really at the forefront of the agent trend. There is Ryan from DLK Labs had this lot of very accurate car data, like more accurate than what you get from GPS. And he's using that to do like battery pricing models. And that's something that people pay like, what is it, $3 per driver I don't know the exact numbers, but that's something that just seems intuitively very valuable to me. If you look at Pratt & Whitney, if you look at engine suppliers, and these other things, and then you look at like electric car, I'm driving an electric car, what can how do I press that battery? How do I make sure that is maintained, and maintainable and reliable? It seems actually very good for that, and it comes across car manufacturers that want data out of this. Having all of that can be very useful.
May I just ask the crowd real quick? Does anyone here use X? And then has anyone noticed a huge trend in your timeline of agents or like bots posting in your timelines, cringeworthy stuff all the time? Raise your hands. Yeah, okay. That's happening all the time. Now imagine these agents actually being trained on real data from Vanna and not sounding like cringe lords. Now that sounds like a good reason for data being accessible to agents, especially in a decentralized context.
Okay, you keep giving me very nice segues to the next thing I'm thinking, because we just saw what is being called season, right? Agents and of crypto AI kind of closing, and we're all starting to keep what is season 2. But I think before we talk about what is season 2, but what to do, what did we learn in season 1? Like, what did we learn about what's useful infrastructure? What did we learn about what are stupid use cases? Was there any good learning from season 1?
AI meme coin.
Yeah.
So one of the reasons actually I got off AI was I think it's quite hard. It's a very hard topic where we really talked out into AI. There's a lot of multi-party into that. But I think one thing I was actually doing some event with Eliza. But what I figured out is there's a lot of people in Web3 teaching you what exactly AI is, and then you yourself knowing what AI is, and then start to debate in yourself. What are they talking about? And why are they teaching us AI? That's a doubt I have a lot of time. I started realizing there's a lot of people trying to teach you AI when they don't understand AI. So that's one thing. And then I think meme coin is a good attention economy attraction, but the thing is, we can't just expect everyone to just launch an AI agent. And then, like what Tim just said, underneath my thread, I might have multiple AI agents just posting random stuff that it's just boring now. I think we want to look back into what valuable stuff we can create, and then what exactly we need. In Web3, one thing good is that token is the attention, right? You have the token, you can attract more attention into understanding your project. That's what Eliza did good. I think the model of Eliza has hit in hard especially in the open source kind of a framework kind of a perspective, where we see doesn't 10K people actually start contributing into the framework, even though the framework start getting very heavy, very hard to use. But you don't normally see, it's very hard to see it in the traditional open source world, where you need to start operating, you need to start marketing, and then you need to have a very good thesis where you attract people. But for Eliza, everyone just rush it in, even though because of obviously token price is one of the reasons, but still we need to look in that why people suddenly rush it in, so and then learn from it. I think that's one of the learning that I took.
I mean, I think that people are learning to correlate. I hope that people are learning to correlate value and things like error or traditional metrics of how much use are you getting. Like with Mono, one of the things that was this prominence is, holy shit, we got 200K Reddit users data and then we trained on it. And that was, it was so I first exposed to crypto in 2021. looked around the market and I had no idea what was going on. I think it's starting to make more sense. And I think that part of that is also the market enforcing that things serve a purpose and there's a higher standard for what. I think that there's going to be higher and higher standards, right? There have to be higher and higher standards.
Yeah, just right on that point. Like, the first wave of these Twitter agents, which are essentially like, an LLM call with a token attached to it, which is cool. Like, it's a good first, sense of what this could be, that, okay, you post a tweet and then you have an agent replying to it. I mean, that gets saturated, instantly, right? You have a billion of them posting, stuff that isn't all that helpful, right? But there's something there, right? And it goes to your point around, Eliza being really easy to use, and it attracted all this attention, and now you have people wanting to build agents, and it's just an evolution process. It's there has to be some kind of real, it's an overused word, but utility to it. If you're going to have an agent replying to tweets, what is it doing? What's the utility of it? So we'll get there. I think this is just the first phase. You get a lot of attention. People come in, they want to ship, tons and tons of agents, but now there's a lot of those will wash out, and the ones that are providing value will stay.
Yeah, what's a viral app and it's a useful deep tech culture?
I think, I love that everyone called out Eliza, because I hope that we all give Shah a ton of credit for season 1, right? And that the Eliza framework did something truly brilliant, which was align token incentives to the builder economy. And what happened is you had 300 or 400 devs realize that they could actually positively affect their own investment in the AI 16Z token. And they could also maybe receive some as grants. And so everyone built everything into Eliza as quickly as possible. Every endpoint, every API, every service, literally every company was getting out there oh yeah, we integrated with Eliza too. And now Shah has the opportunity with his V2 that he's working on to address more interesting agent behaviors besides just, Twitter posting or making voice, that sort of thing. And they care about life loops, they care about simulation, and I'm very happy to have been part of that as well, even while I'm building my own framework, right? But when we come back to this question about, what does season 2 look like? It struck me that I just randomly ran into the Reserve team today, and Reserve is building things called decentralized token folios, right? And it's essentially index funds for coins. And Virtuals just launched one of just all the various agents that they think are good on the Virtuals platform, and you can just buy their one massive token instead of individuals. And I was like, guys, what if we just have one of my autonomous agents make one of your DTFs and run it on Twitter and let Twitter plays index fund management through a provably fair, incredibly neutral autonomous agent? That sounds like fun, right? That sounds like something that people would be interested in. Okay, so we'll build that. But also it was what a cool opportunity that we're seeing with decentralized services now hooked into what I hope becomes season 2.
So can I ask a quick question about, of course, on the panel? What does an agent mean to you?
Two things. I can either delegate my will to something and it executes, or it's executing its own will. That's an agent to me. So we go towards the spectrum of autonomy.
Yeah, the key piece of that is that the agent itself has to have the ability to have autonomy of its own nature, right? Because there's a little bit of this, someone will call something an agent, but it's really just a scripted out process. So there has to be some element of it where the agent is able to act of its own will, to your point, right? That's a core component of it. That has to be there. If it's not there, it's not an agent.
Or is there bits on a GPU?
I think there are loops an agent can get into where it is making decisions of its own will, for lack of a better word. I mean, there's a semantic argument about it's a will, but there's something that looks like will. If it's in a loop where it's making decisions on its own.
Here's what's great. We know this works because we did it even in the 1990s and 2000s with really simple scripts. If you put enough of them together in a physical space with a time variable, you end up with emergent behavior. Things go weird. We know it works. The architecture I'm working on that we're going to deploy on Inori, literally, it's inside out the movie. It's swarms inside the head of the agent. That's where we get that chaotic element of hopefully, I don't think free will exactly, but some sort of autonomy.
I think agent to me is something that obviously it's executing a will, but sometimes it might bug out. It might go into a direction that you never expected it will go. I think it's the moment where you realize it's actually start to thinking differently. the same thing, like, you know, thinking in a way where it might start to aggregate all the information they have and then start thinking in a way where you never expect them to think.
Okay, I like those answers.
Well, and think about it for a second. I asked Ilya in one of the previous panels, like, what do you think the next directions for like autonomous learning are? Like on the fly, like not just running one model on a GPU, but like being able to rapidly train something new that it just learned into its future decision-making processes. We have stuff like that. There's new cool stuff in Inception coming out with diffusion networks for generative text. There's tons of stuff to explore. Hopefully season 2.
Just real quick, the same question back to you. What do you think?
What? I know it when I see it.
Ooh, I like that. That's like actually an intelligent point. You'll know it when you see it. There's no predefined test, like a Turing test for this.
It goes back to what you said. It's like there is some element of unpredictability to it. Like you could do the whole semantic argument about like, what is that? But like that's in there somewhere. It's like, so you're watching this autonomy, like you know it when you see it. Like you watch the loop happen and you're like, okay, I totally didn't expect that at all. Like there's something in there that's autonomous.
Something like an actual like entity, a being, you know?
Seems like it, yeah.
It's going to be an interesting year with a couple of years of meta questions of what are humans, what are AIs. But yeah, that's
100%.
I'm going to look back on this question like 2 years ago, 2 years later.
Well, let's think about this though, because story protocol, right? We can actually track it over time because if we start hooking the agents into story, they can literally submit like their philosophies as they're changing, or we're changing, like adding things to their models. This is like, we're going to have like records of like intelligence growth. That is now possible.
Oh, on story.
So if we look at season 1 and we stick on the Eliza case here, one interesting thing, if you step back and look at what Eliza actually did, it created a framework that might be exposing the most composability we've ever seen in Web3. For all this composability that we've spoken about, we now have a computer interface that can talk to hundreds of different protocols through all the plugins that were pushed. How important is the composability story here? Is it underhyped? Is it
so important? Because think about this. Now you can throw that repo into any other LLM and say, here's everything. Pick and choose what we need to do this other thing for an agent. Like it is essentially like the Rosetta Stone for agents right now. And I dig that. I think that's a valuable, I call it like the technical artifact of our decade, right? It is something that it is so complete in its participation that we can derive more from it. Now, of course, that means that it doesn't have much of a moat because it is so open, right? Literally, if someone wants to convert it fully to Rust or fully to Python or some other like framework outside of TypeScript, they can. If they want to customize it for a completely different use case, they can. But now they have this giant record of every service and composable entity that you just talked about. You can tell.
The importance of Eliza is not just framework anymore, since it's like composable. It's more like become a Wikipedia.
Yes.
We're kind of everyone trying to contribute into that. You don't really see it like you know in the traditional Web2 kind of AI framework, but whether it's Auto GPT or Meta GPT, but no matter whether it's an Auto GPT or Meta GPT, it seems to be still hooked in within the AI industry. It haven't yet breakthrough into a lot of people. But when we're looking at Eliza, we see people working on AI. We see people working on Web3. We see people investor, and then we see actually a lot of normal user got hooked in. I think we still need to be grateful to the fact that token prices was really the one that attract a lot of people coming in. But when we look back on this, it's like, are we going to have a second framework like this? Probably hard, because we probably like not going to be that.
I think so. We're actually running out of time, and I want to do just one last 30 seconds each. Easy question. What's the one unsolved problem in decentralized AI that you think is going to create the next big opportunity?
Okay, well, now it's just my pitch for my company because like I really feel it's that we have 3 possible verticals that I care about: decentralization, secure transactions themselves, such as money, Bitcoin, everything like it, secure computation, deterministically, ZK, Ethereum, everything like it, secure oracles, but fully decentralized, and then provide valuable services for the things that are not black and white. That's the third vertical, and it's underserved. That's why I'm building Nori. So that's my 30 seconds.
Oh, second. I'll not talk about a story. I think what the ownership is important, but I do believe that how we use sensitive data for training, like the very decentralized way, the sovereignty of data is a very important thing because data is running out. Data is the new oil. Data will be the new key milestone for better AI model. Like bullish on data.
Yeah, data is a huge piece of it. I mean, not to talk around, but it's fundamentally, it's access to compute. I mean, that's just the only way I can look at the world being so deep in this, but it's fundamentally how many chips can we create? I mean, if you really go macro, how much energy can we produce? How many chips can we make? How can we bring compute to market? And then how can we distribute it and get it into people's hands? So it's not an unsolved problem per se. It's something that's like evolving, but the more we can do that, the more we can push those boundaries, the better.
Yeah, I think having the data to make really intelligent systems and the confidence from the user that their data is being treated and respected, basically what we're building in Bond. That I as a user can go and I can let my data be used in this AI training run or let my data be part of a collective operation that then enhances my life. I think building those great user experiences and building in a way that's really respectful of the user, that's going to be a really big unlock because we're hitting a data wall 1 and 2, like we're hitting a intelligence scale to some extent. You know, we can keep throwing billions at computer, we will. And then we can start building, we can take the LLMs as they will be in the next 3 or 4 years and put them into truly intelligent systems where the individual data, the individual context may count. Think about me trying to make an agent for Andrew with no clue what he actually likes. You can scale an intelligent model. I'd rather take the models and put in the data, put in the context, and put in the ability to actually make use and interact with people in their daily lives and society implications armed with the data and actually use these models.
Super. Thank you all.
Thanks, everybody.
Yes, that's about. There's still more of the massive.